In this video, we are going to solve very interesting problem using generative AI, and we are going to call it semantic mapping using generative AI. So in real world, we often have to take data from one system and then have to match it against different system. Though the semantic meaning of the text or a string is probably going to be same in both the system, but this traditional approach often gets failed if there is dot or extra spaces in one of the string. So can we solve that problem using generative AI? And that's what we are planning to cover over here. So in our demo, we are going to deal with source and destination list. This source and destination list, we are going to pass it to an endpoint. This endpoint we are going to create it using Python and Fast API. And under the hood, it's going to call the generative AI model. So we are going to have demo with the OpenAI model, and we are going to have demo with Gemini model as well. And then our idea is to have the output like this, where we are going to get a match between the strings based on their semantic meaning. In this case, as you can see in the source list, we do have a question like what is your first name, what is your birthday, or where were you born? And in the destination, we do have the same thing, but the phrases is something different. And this we are going to solve it using generative AI. So at the end, we should be getting an output like this, where the source would be having the data from this list, and then the destination string having the data from this list. And it will also provide the confidence score on this particular mapping. What is your first name is going to be mapped with may I know your given name, because the semantic meaning is same. Then we have like what is your birthday. This is going to match with your date of birth, please. And then where were you born, the place of your birth. Before we go into the code, we have to install certain packages that we can install it using all this command, because we are going to expose our endpoint in Python, and for that we are going to use Fast API. That you can install it using pip install Fast API. Then we are going to have UVCon server to run these endpoints. Then we are primarily going to use LlamaIndex generative AI framework over here, and because we are going to use Gemini and OpenAI models, so we do have to install those packages as well. So now let's go over the code. So I have created 3 Python files over here. As you can see, the main one is going to be the processor one. So let's go to this processor file first, and here I have defined a method. This particular method is going to take 2 input parameter. One is going to be the list of source and another is going to be destination. And then actually we have to invoke our LLM model, and this is using OpenAI model. So I am primarily using GPT-4o, and here actually we can invoke the model like this. So OpenAI is something which is going to come from LlamaIndex LLM OpenAI. So we can import OpenAI from here, and then we can use this OpenAI to invoke a model. If we are not passing the GPT-4o parameter, then by default it's going to take the GPT 3.5 turbo. So if you want to go ahead with that, you can also utilize it. And then actually we are doing some prompt engineering to pass the instruction what exactly it has to do. And this prompt is a critical part of this application, because that's how we are passing our instruction to this model, what exactly we need and how it has to perform. So the template is going to be something like this. You will be provided a source and destination list containing strings. You need to take a string one by one from source list until it's empty and try to match it with the string in the destination list. Please do note that you need to map the string based on the semantic meaning and not just based on the string similarity. So here we are specifically saying like, okay, you have to map the strings based on the semantic meaning and not just based on the string similarity. If you are able to find any match for the given text in the source list, please do say no match found in the destination string only. So there could be certain cases where you are passing something in the source list and there is no match in the destination one. So we are passing a separate instruction for that. Like if you are not able to find a match, then you can also mention no match found. And also because as we have seen in our diagram, we are also asking it to provide the confidence or match score. For that actually we are passing a different instructions over here, which is going to be please also mention the matching score based on your confidence on the mapping. The match score should be a number between 0 to 100, where 0 means no match and 100 means perfect match. Because we are passing this source and destination list, so this is how we can pass it as a variable in the prompt. So here we are saying source list question. This is going to be like we can just put it in the curly braces, and then there is a destination list question that we can put it in the curly braces. And after that we are just asking to provide its response. This is from the prompt side. Now how we are going to pass this prompt to the model. So for that we are going to use something called prompt template, and this prompt template is also coming from LlamaIndex.core package only. So we can take it from here, then we can pass this particular template. So under prompt template, there is a parameter for template. So we can pass a template, whatever we have defined over here. And then we are passing something called output parser. So this output parser would be useful where you want to get a structured output from your LLM model. And also you can define it based on your criteria. So here we are passing the output parser. This output parser is basically coming from here. And this output parser, we are passing something called pydantic output parser. Again, pydantic output parser is coming from LlamaIndex core output parser package only. So this pydantic output parser, we can take it and use it to define a structured output in our case. But you can see this pydantic output parser is having something called output class, and here you can define your class. I have defined my class like this. Here you can see the output class I have defined as match output, and this match output is basically coming from this base module. This base module is something which we have defined. So here you can see like we do have base.py. Let me click on this one, and here you can see the match out. So we have defined a class match output. It is based on the class base model, and this base model is coming from the pydantic. So we have to define our pydantic class to get a structured output based on our requirements. So in this case, because we want something like source string destination mass core, so we have defined our class like that, and this is going to help us to get our output in the structured format. Because we have defined our class, so we can just pass it like this into match output. This will create an output parser, and then this output parser we can pass it in the prompt template. Now once your prompt is defined, then we have to chat with our LLM, and for that we have to convert it into a message. So for this we are using this prompt and then using dot format message, and this format message gives us ability to pass our input variables as well. In this prompt we do have two variables, and we need to pass values to these two variables. We have got this source list and destination list, and these variables are also defined as a source and destination list, so we can just assign it like this. Now it will make sure like when we are getting the output externally from our API, then it is going to get passed to it, and then the LLM would be having these messages with those variables on which we can chat on. So finally, because our LLM has been defined at the initial stage, so once everything is done, we just have to chat with this. So here we can use LLM.chat and message, and once you pass this message, then we are going to get a response. So this LLM response is going to return to us chat response, and this chat response is having like all kind of information. So if I just go ahead and print the LLM response, then along with the content, it's going to give us some metadata information also, where we have the details about the input token, output token, the system message and all those things. But here actually we are not bothered about additional details. We just want to go to the content section of it. So for that, just to navigate to content section of it, we have to use something like LLM response, then dot message, and then dot content. So once you go to the content section, then it will only give you the content which we are willing to show to our end users. The next part of this application would be the endpoint. So for that, we can go to main.py file, and you can see in this main py file, we are trying to create post endpoint where actually we can go ahead and pass our source and destination list. First of all, actually we are creating an app instance of Fast API. Fast API is something which is coming from Fast API module. Once we have the app instance, then we can just go ahead and create the post endpoint using this decorator. The final endpoint what we are mentioning is going to be the localhost, and then the match section, you can just name it per your requirement. And then I'm passing an input, and this is of match input. Now this match input is also something which is coming from base class. So let me go to base class, and here you can see the match input. So this class is defining the input. So we just wanted to make sure list which is being passed to us, this should be containing a list, and it should be having a string data under it. And similarly, we have just defined a destination list. Under that also we should be having a string data. Now this list is something which is coming from this typing. So you have to make sure like you are importing list from this typing module only. We can just pass it like this, and then you would be having your pydantic class for input also defined. Here we are just defining a parameter, and this item is a parameter of this match input class which we have defined, and then we can use this item parameter to get the source and destination list. So now we have to invoke our method under this endpoint. So if someone is hitting this endpoint, then our method should get invoked. So for that, we are importing this get match text from our processor module. Once we have this method defined over here, we just have to pass our input. So this is going to be item.sourceList, one variable, and then we are going going to have item.destination list, another variable. To get the output in a proper JSON format, we are going to use json.loads, and under that we are going to pass this output. Before running the code, let me just try to print raw output without using the json.loads and see like what kind of output we get and why do we need to have json.loads over here. And to run this, we are going to use a UVCon because we are using fast API. It's going to run on the UVCon server, and then we are going to pass the main. Main is something where our endpoint is declared, and then we are going to pass app and then reload. And now our endpoint is up and running. We just try to go to Postman, and in the post you can see like we do have source list and destination list defined over here. We do have a post endpoint, and then we are going to hit this endpoint. So it's a localhost 800, and the endpoint which we have defined, it's going to be match. And just to pass this input on the Postman, I went over the body, then selected a raw, and then selected a JSON, and then actually we can paste our input like this. Now if I have to go over few of the string which we have highlighted over here, and then you can see one of the string is what is your favorite color, and here you have your preferred color. So the semantic meaning is same, but the phrasing is something different in both the text. Similarly, we have which genre of music do you prefer. Here we have your music taste. So now just let me try to hit this endpoint and see what output we get. And we have got output like this. It's in the JSON, but it's not in preferred format. So we could see like, okay, there is a source string, there is a destination string, there is a mass score, but it's not something which is readable. Again, just go back to my output and just try to add json.loads. So let me go back to this endpoint and try to run this again. We have got the output as required. I'm getting like source string, what is your first name, and it has been correctly matched with may I know your given name. Then we do have like when is your birthday. This has been matched with your date of birth, please, and where were you born, the place of your birth. Let me just try to shuffle it a bit. So I'm just going to put it at the top. I've shuffled few strings here and there just to make sure this LLM model is not following any specific pattern, and we should be able to get the required output. So let me try to hit this again. Okay, so we are getting some error in this case. So let me just go back to raw output. Now I will try to run this, and you can see like we are getting output when we are trying to print it a raw output, and this is getting failed while decoding into a JSON. One thing what you can notice over here, there could be certain things that we don't want in the output and they may appear. Like you can see over here, we are getting this triple quote JSON. So what I can do in this case, go to our processor.py and just pass a prompt in this. Please remove from the final response. So I'm asking LLM only to handle it by itself. So let me just save it. And this time it's not coming. So let me try to go back to my main.py file again and try to convert it into a JSON again. So I will try to hit this endpoint one more time, and this time I was able to get the output. Here you can see like what is your first name. This is okay, but I have shuffled few things. So again it was able to match it even though like it was not in the same hierarchy. One more example, where were you born? In the list was matching to may I know your given name, but when I go and see the output, where were you born, it is correctly matched with the place of your birth. So this is one thing. Other variation what we can try is, giving extra spaces in one of the strings. So here you can see like I have just tried to pass what is your first name, and in the between your and first there are two extra spaces, and then actually we try to run it over our model, and in this case also it was able to match it perfectly. And why this is happening, because even after providing the extra spaces, the semantic meaning of the text is not getting changed. So this is from OpenAI, and we will try to achieve same using Gemini model as well. In this code, actually, we will try to achieve the same functionality, but using Gemini model. Here, actually, we have to have our Google API key, which we can define in our environment file. And just to load the data from environment file, we can use something like load.environment, and then take the value from the environment file and then pass it to a API key. And only change what we are going to do over here is like instead of invoking the OpenAI model, we are going to use Gemini model, which is going to come from LlamaIndex LLM Gemini. And then under Gemini, you can see like we can pass all these parameters. So as of now, we are passing 3 parameters. One is going to be API key. Another is going to be model. Under Gemini, we are using Gemini 1.5 Pro. Then the same template, we are going to pass it over here with the same structure. And then in the main class, we are going to have our endpoint defined. So now let me try to run this with the Gemini. We are going to follow same command. And we can see from OpenAI, we are getting accuracy like 95, 90, 90, 85. So we'll try to run the same with the Gemini model and we'll see like what output we get, and we'll try to hit the same. And we can see the matching is definitely correct, but I can also see there are some variation in the confidence. So Gemini is pretty much 100% confident this string is going to match with this one. But at least from the LLM model perspective, we can say any kind of generative AI model, whether it's a OpenAI or whether it's a Gemini, it's able to perform the semantic meaning just by passing a prompt in a certain way. And we don't have to do anything else on top of it. We don't have to have any kind of mapping. We don't have to write any additional logic, and it is able to handle any kind of discrepancy in the text as well, whether it's coming in the form of spaces or any dot. It's just that if the semantic meanings are same of the text, then it should be able to provide you the correct result. That's all for this video. Thank you for watching.